Okay, we're looking at Minitest 27 and question 2. So we've got particles and they're passing over a smooth pulley. We're given the mass, well, we're given the masses of each of them in terms of m, and they're attached to a light, inextensible string, and the system is released from rest. Okay, so first thing I want to do is sketch that out. So there's my pulley, there's my string and my two particles. So I know that when this is released from rest, B is going to move downwards because B has obviously got a greater mass than A. So other forces in this diagram, they've both got tension in the string. So that's what's going to be pulling A upwards and stopping B from just free falling. And they are both going to move with the same acceleration, but B is obviously going to be moving downwards and A is going to move up. So first thing I'm asked to do in the question is actually come up with the equation of motion for A and then the equation of motion for B. And that's what I want to do anyway, is just look at them as two separate things. So if we look at A, so A has got tension going up and mg going down, and A is going to be moving upwards. Now, it doesn't actually matter if I know whether A is moving up or B is moving down, as long as I appreciate that if A is going up, B is going the opposite direction. So if I use F equals ma for A and take up as positive, so the resultant upward force on A is the tension minus mg, and that equals its mass, which is m, multiplied by its acceleration. So there's my equation for A. So for B, so B has also got tension, and that tension will have the same value because the string is light, and then it's got its weight of 3mg working down, and B is going to be moving down, and it will be moving down with the same acceleration that A is moving up, because the string is inextensible. So going back to our original diagram, whatever acceleration B is moving down with, they're attached by an inextensible string, so a string that doesn't stretch. So A will be moving up with the same acceleration. So for for particle B, I'm going to take down as positive. So I'm going to use F equals ma, taking down as positive. So 3mg minus T is its mass, which is 3m, times acceleration. And there's my equation of motion for B, and it didn't ask me, let's just go back to the question. It didn't ask me to do anything with those, so it didn't need to rearrange or anything like that. So that's my answer to part 1, and that's my answer, sorry, on the wrong screen. That's my answer to part 1, and that's my answer to part 2. Okay, and then find the magnitude of the acceleration, give your answer in terms of g. So let's just say give your answer in terms of g. Okay, so I've got 2 simultaneous equations to solve. The significance, so there's my 2 equations, and the significance of leaving my answer in terms of g is basically I just don't want to substitute in that g is 9.8. So I've got t minus mg equals ma, and then I've got 3mg minus t equals ma. And with this type of question, what will always happen is when you've come up with your 2 equations, if you add them, the t's are always going to cancel because I've got t minus t, so that's cancelling, and I've got, so just be careful, I'm adding, so I've got 3mg and minus 3mg, so if I add those together, that's 2mg, and I've got ma plus 3ma, so 4ma, so those m's can cancel, so a is 2g, and then I can divide by the 4, so a is g over 2, and let's still give units for that answer.